Under 8.10 or 10, a theoretical approach to finding the mean and standard deviation of the original data given the mean and the standard deviation of the coded data. And somebody is telling us in example 17 rather, data are coded using y is equals to x minus 150 all over 50. And the mean of the coded data, that is the mean of y, the mean of the coded data is, let's talk about the mean of the coded data EY, which is 5.1. And the standard deviation of the coded data, the standard deviation of the coded data is 2.5. Let us keep that in mind. We are going to use that information. Find the mean of the original data. First of all, we must understand that x has been coded this way to give us the value of y. So if you want to get the very original kind of data, we must be prepared to make x the subject of the formula. And because the question is asking us, find the mean of the original data, we have no choice other than making x the subject of the formula. And as you can see, this is easy, it's simply algebra. So x is given by 50y plus 150. That is the value of x. What is the mean of this original data? That means we are talking about ex, which is given by, as much as we have always been understanding that ex, or rather eax plus b is equals to a multiplied by ex plus b. That means ex is where a is 50, so 50 multiplied by the e of y, or the expected value of y, which is 5.1, of course now plus 150. 50 times 5.1 is I think 255. This is 255 plus 150. This is supposed to be 250 255 plus 150, that is 255 plus 150, this is 405. 255 plus 150 is 405. Fine. Having said that, I think it is important to note that we are now expected to calculate the value of the standard deviation of the original data. The standard deviation of the original data. Standard deviation of the original data, of x rather, of x. We have to remember something, that the standard deviation is the square root of the variance. The standard deviation is the square root of the variance. And before we can even go far, because in our question we've been given the standard deviation of y to be 2.5, it is important to know that the variance of y is supposed to be 2.5 squared. Because if you want to get the standard deviation was the root of the variance. So if you want to get the variance, then you must square the, or rather, the standard deviation squared is actually the variance, because when you square both sides, then you automatically eliminate the square root sign. That was very important. So the variance of, we'll have to start from the variance. The variance of x, which is, of course, the variance of 50y plus 150, which gives us something, which gives us now the 50 squared times, of course, the variance of y times the variance of y. And remember, the variance of y has been calculated to be 2.5 squared. You must take care of this. That is where the trick of this question is. So that means 50 squared multiplied by 2.5 squared, obviously you will get something to do with 15,625, 15,625. And remember, this is the variance of x, which is equals to 15,625. The question is very clear and very specific that we are looking for the standard deviation of x. So the standard deviation of x is, of course, the root of the variance of x, which is 15,625, and the final answer is 125. This question is a bit tricky. Please take care and note how to apply the knowledge which you learned earlier, of course, between standard deviation and the variance. Otherwise, once you remember that, it's as easy as it can appear. All right?